Hi everybody, my name is Mutwana. So without further ado, let's get started. So when you finish in just a few minutes to come, then you should be able to solve these equation. It's easy like that, okay? So now before we get started, right, I know there's a lot of listen, this is very, very crucial. If this video, look, what I'm saying is always give me feedback, because when you write a feedback, then I know exactly, oh, there are a lot of brothers and sisters who need my time, who need my help. But if you don't give me feedback, then I quickly picture like, oh, maybe they don't interested in this type of content, or they don't want to learn this type of physics, because I'm trying to give you an excellent coming from the continent of Africa, showing what we can offer to the world. Now, so before we get started, just come right here. If you're new, okay, come right here. Please subscribe right here. Subscribe and share. I love my continental brother. That's why I got some little picture here to represent. You see what I'm saying? And apart from that, it's very, very important for you to go and visit our program where we feed people, homeless people, and people who are vulnerable. In general, people vulnerable, right? So just visit Mtwana Nkosi. Both all the social media I represent using that name, Mtwana Nkosi, which is my name. You can go to Facebook, Instagram, and all the social media and the social sites, Mtwana Nkosi, and then you can see how we feed people, how we raise people, because now we can't wait for the people to do everything for us. That's me right there. Yeah, that's me, that's my mom and her friends. So let's get to the business, because that has nothing to do with this. So the question say feedback is very, very crucial. Leave a comments below. So they say battery with the internal resistance. So any battery, it always has an internal resistor. What is internal resistance? Let's assume this is a battery. So internal resistance will represent using small r. So now let's say there's a flow of the current, means the current passed here, but whenever the current leaves, that's what we call positive charge. But where the current enter, that's a negative charge of a battery. Okay, so now we always have it, since the current is flowing, so different battery, it has a different internal resistor which resists the flow of the current inside the battery. Quickly before we get started, because I want you to get familiar with this. Okay, number two, okay, if let's say you have this we call cell. Look, this is positive, this is negative. When you write positive, write longer line, because here is where the current leaves. So we write n is a cell. But if it's more than one cell, for example here, look, if I add, this is cell here. Now let's assume, let me add more cell. So then instead of call cell, we call it battery. Means, okay, let me do this, shows me. So this positive, this is negative, but now this is going to be positive again, this is negative. So you see we have a cell. So if it's more than one cell, we call it battery, okay? Now let's get to the question now. So now you know how to differentiate battery and a cell, and where the current leave is where the positive charge. So for this case here, look, this internal, this always like a battery. So we got cell, so together is the battery, and here at the end of this battery we have a voltmeter. So the voltmeter is going to measure how many voltage pass through this battery. This is cell, so together make a battery, and this is internal resistance of that battery, which is inside the battery. Okay, so this is like the whole battery. Okay, the whole battery. Okay, now let's go to the question. They say define the term EMF of battery. So EMF, this is electromotive force of a, or you can say this is maximum energy by the battery. Oh, so the battery inside, it has a maximum energy inside this battery. We have a something called EMF. So that one we call is the EMF is the maximum energy provided by the work. Oh, so the battery has a work done because it works. You see, but the work done per coulomb which pass through that battery, that's what we call EMF. Or sometimes they say is the electromotive force. See, the electromotive force, is the energy which is provided, by that battery per coulomb. Okay, so that's electromotive EMF, electromotive force. So we find EMF inside the battery. Okay, now Or if you don't want to say that, just say this is a work done by battery to move unit per coulomb of a charge across it. Because look, there's a charger which is passing through this battery. You see? So that work done by battery, which have, okay, the movement of coulomb of a charger, means it have the movement of those charger. We call what? EMF, or electromotive. EMF is the abbreviation of electromotive force. Electromotive force. Okay, so EMF we done, but I'm going to show you the right definition there, or you can check in some books. The important thing for you to understand. Now let's go to the second one. They say give a reason, number 2, why the voltmeter reading decreased. Why the voltmeter reading decreased? But it mentions something here. Okay, they say define EMF. I was supposed to read the question here. Now they say now the reading of the voltmeter is gonna decrease. By what? By 1.5 when the switch is closed. When the switch is closed. Let's see, what do I mean by that? Now remember, now this is positive. Before we close, this is positive. The current is going to be moving here because this is positive. So there's going to be current, and when the current comes in, it's going to meet up with the resistor. Resistor always resists the flow of the current. So it's going to be like, hey, come down a little bit, come down a little bit. Don't be rough, but it's going to pass through here. That current is going to pass through. And then here, this is voltmeter. Voltmeter, we use it to measure how many current, which will represent current by letter I, is going to be passing through the circuit. And this current is going to come, but the sad and funny part of this current is going to split. Some's going to go to the top, and some's going to go to the bottom. Means some's going to go there, some's going to go to the bottom. And he's going to meet up with a big resistor and his small resistor. But remember, let's say this is, let's assume our current is, let's say it's 5, let's say 8 ampere. We don't know, assumption. If it comes in, it's going to split. But look, this is more resistor, 25 ohm, which is resistor for the current. Also, we have a 15 ohm here. So now you think from this 8, we don't know how, we just assume for now, because I want you to understand. Let's assume it's split. Is it more current is going to pass to the top or the bottom? The more current is going to pass to the bottom because there's a small resistor. Small resistor means it's going to resist a little, not so much, means more current is going to pass to the bottom and less current is going to pass to the top because there's a more resistance, like, hey, don't come here, go back or stop it. We're going to try to pass, but it's going to be in a hard way because there's a more resistance here. This assumption. So 8 ampere do not involve, okay, in a calculation, just example. And then what happened is going to come, they're going to join together all the way. But before it was closed, it's top here. But now if it closed, means the current is going to pass again all the way. So now the problem is when it was open, let me explain so that we answer this question. When it was open, it was only stop here. So meaning, look, the current is going to be leaving here all the way, and here also positive. But this one did not have any effect because look, the current is going to go all the way. Some's going to split all the way and then come together, but it's going to stop here. So the electromotive internal resistance R of a battery, it was not affected because it was open. So if we close, it's going to cause, look, when you close this, means it's going to be closed now. Oh, so when you close, remember, if you have a battery, let's say this is a battery, okay? A battery, okay, battery, or battery. Sometimes if you use, let's say, torch or any device which has a battery, the battery sometimes get hot. You see? Why? Because some energy is converted into heat. But what happened? Because inside the battery, we know there's internal resistance now. So when you close, means this stuff is going to pass here. Means you have internal resistance. So when it's trying to resist that current, means it's going to change that energy to the heat energy. And that is going to cause the loss of what? Of because they say the voltmeter is going to decrease by, so now the voltmeter is going to read what? Way lesser. Because some of the energy is being converted to heat energy, because this internal resistance, it resists the flow of this current. So the energy is going to be energy, or you can say this current or electron, which is going to be flowing, but for this case it's going to be current. So I'm saying, so let's say this is very, very crucial concept. This has nothing to do with the electron, but I want you to understand. For this case, you know the current is going to be flow this way. But when the direction of electron is always other way around of the current, means electrons will flow opposite of the current. But please do not involve the electronics now. This has nothing to do with electronics. This is currents, okay? So remove this electronics. So we can use, you can say, okay, when the charge are flowing, or when the energy, this energy which is going to be passing here, the internal resistance of the battery, is going to be converted to the heat energy. So the reason why there's a loss of voltage, which is 1.5, because they say this will be decreased, because the energy is converted to the heat in the battery due to the internal resistance of the battery. Okay, so that one we done. And if you want to get the right definition, okay, let me just get this on here quick, just a second. Oh my God, sorry. Okay, I got this one for you. So you can simply read that. So okay, so for the 8.1 it was okay, define EMF. So define EMF, this is a definition that EMF is the maximum energy provided by a battery. You see, is the maximum energy provided, or if you don't want to say maximum energy, you can say the work done provided by a battery per coulomb unit charge passing through it. Okay, or if you don't want to do that, you can say work done by a battery that move unit coulomb of charge across the circuit. You can memorize that. Okay, now the second one, they say Y is going to be decrease of 1.5 because just like I say this is because the energy is converting to heat in the battery due to the internal resistance. Because of it, it's going to be resist the flow of the current. Current come this way, the resistance is going to say, hey, don't come. Okay, cool. So 1.1 and 1.2 we done already. So 8.2, excuse me, we done already. Now let's go to 8.3. 8.3. Let's go quick. 8.3. Okay, I'm trying to check it out. Okay, 8.3. Sorry. And by the way, okay, so some people, you know, they want to support the movement. You know, like I say, go to Mtwana and Nkosi. There, you know, we have a where you can give a support whenever you feel like there's a need for you to do that. We appreciate. I'm not saying you must, you know, and whenever it's convenient for you, we appreciate it, you know. Okay, now let's go. And also you can visit our store merchandise, where we offer some merchandise, selling some you know, top of the line merchandise, you know, some outfits and caps and, you know, outfits, and then you can benefit from that. You see? Okay, now let's go. So don't forget to go to Mtwana and Nkosi, and you know, so we can see what we do for the community, man. This one right here, Mtwana and Nkosi. Now let's continue to 8.31. 8.31, they say, how about the following when the switch S is closed? So now this switch S is closed. We have said, okay, it's closed. Now they say the reading of the ammeter. So what the reading of ammeter? Ammeter, it always means the one here. Ammeter is always read with the current to represent using the letter I. Now look, if this is closed means, look, face, I want to know if this closed means the current is going to be passing all the even if it's open, the current you know is going to be passing all the way, split, go, meet up again, and then it's going to pass again. Means it's going to be circulation because it's closed. But when it's open, it's only stop here. Now let's find that current passes when it's open. When it's closed, my part, because they say when it's closed here, this switch is closed. So we're going to say V equal to I R. But let me deal with this one. But if I deal with this, remember they say here it's going to be decrease in voltage. So decrease in voltage because there was the effect of this internal resistance. So now I'm going to say this is from Ohm's law. Okay, so I'm going to say V equal to I R. But now we're not going to use this bigger R because now let me deal with the small R. Here, the one is inside the battery for this case now. But I know my voltage which we're decreasing. And why do I use R? Because R is the one which caused the decrease in voltage. And which was that voltage? Which was 1.5. 1.5 equal to, I'm looking for the current, times internal resistance. Internal resistance, I do know. The internal resistance is 0.5. So I'm going to say 0.5 here. And then let me find my I. So it's easy. So I can simply divide it by 0.5. I can divide by 5 and this cancel. So our current which is going to pass is going to be 3 what? Ampere. Oh, so here, for these two when it's closed, we're going to have a current which is going to be moving here or leaving here all the way past through the 4 resistor and come here. So this ammeter, which is the device which measure the current flow through the circuit, is going to read 3 ampere. Oh, okay. So now we know. Okay. So we say the current which is going to pass here is going to be 3 ampere. Or you can say here the voltmeter is going to read 3 ampere. And then what happened then? Now let's go to the next question. That's going to be 3 ampere. Now they say here, you're going to have to, okay, if it's exam, make sure you write everything. Everything make part of your solution. See? So 3.8.32 total external resistance on this of the circuit. Total external resistor. Oh, look. So we have two types of resistor. There's an internal resistor. Internal, which is in the one which inside this battery, which is smaller. But for external resistor, for this case, is this one because it's outside the battery. That's called what? External resistor. And then this one, you see, is connected to another 2 resistor. But look, this is very, very crucial now. Whenever we have a resistor, say this is resistor 1, let's say this is resistor 2, this is resistor 3. Call this resistor 1, resistor 2, resistor 3. Some books they write like this. Look, that's a symbol for resist sometime. So they say, oh, Muchwana, of course, you say like this, and then I went to this other book is another way. How no? Don't get confused. It's easy. So this let me say resistor 1, resistor 2, resistor 3. That's another way of drawing a resistor. If your resistor in series like this case here, what you do, you say resistor total, just add all of them. Resistor 1 plus resistor 2 plus resistor 3. Why we do that? Because these resistors are in series. For example, if somebody say, oh, your resistor 1 here, let's say this is 1 ohm, this is 3 ohm, this is 5 ohm. And ohm is the unit for resistor. So we're going to say resistor total equal to, add them all together, 1 ohm plus 3 ohm plus 5 ohm. And this is going to give us 9 ohm. This is going to be the total resistor if our resistor is arranged in series. And another thing also to pay attention on, when the resistors are arranged in series, they all have a difference. Voltmeter means this is going to have its own voltage, and this is going to have its own voltage, and this is going to have its own voltmeter or voltage. Oh, so if the resistors are arranged in series, each one is going to have a different voltage. See? Now let's go to the parallel resistor and how to find total. It's easy. Yeah. Like I say, man, don't forget to go to Twitter course. You can see what we do for the community. You see what I'm saying? We can see there also some merchandise on my website, so we can keep this project going. Okay. And also feel free to donate. I got my website under, in all the tabs whenever it's convenient, right? Okay, cool. Now let's go. So we say then we say here now, okay, about parallel resistor. Now resistor, let's say resistor 1, okay, parallel. What that mean? Look, let's say you got this resistor, you got this resistor, and you got another resistor. All these resistors are in parallel arrangement. This is parallel. Let's say resistor 1, resistor 2, resistor 3. Okay, let's say this is let's say 2 ohm, 1 ohm, and this is, let's say, 6 ohm. So we want to get total resistor. It's way easy. If you want to get total resistor, if it's in parallel arrangement, so you say 1 over resistor total. So you don't just say resistor total equal. You must say 1 over R total. That's how you do it. So you follow the rules. What reason? Mathematics, physics has a rule. So follow the rule. Okay? So constantly complain, follow the rule. So if you want to get total resistance in parallel, say 1 over resistor total equal to 1 over the phase resistor plus 1 over resistor 2 plus 1 over resistor 3. If we have a 5, say again plus 1 over resistor 4. It depends how many of them. That's all. So for example, like this case here, I'm going to say now, let's get resistor total. And then we come back to the question, okay? So for this case, I'm going to say 1 over the resistor total, or let's say resistor parallel for this case here. So say resistor parallel. If you want, you can write is it RP, or you can say R parallel equal to 1 over resistor 1, which is 6. This example, and then go back to the question, 6 ohm, 6 plus 1 over 1 plus 1 over 2. That's all. And then you can say 1 over resistor parallel. This sign means parallel. Or you can use P, simple. You can say use that or that. Equal to 1 over 6 plus 1 over, okay, so you can plug in a calculator. 1 over 6, 1 over 1 plus a half. 1 over 6, 1 over 1 over plus a half. Come here, plug in a calculator. Okay, we say, okay, come in a calculator. Okay, excuse me, sorry. So say 1 over 6, come here, 1 over 6. Say 1 over 6, come here, 1 over 6. Plus 1 over 1, which is like a 1. Plus 1 over 2, plus 1. And then plus fraction, 1 over 2. 1 over 2. I want to show you something very, very important. 1 over 2, excuse me. And this is going to give us 5 over forward. Okay, I didn't see, just disappear. 5 over 3. Okay, 5 over 3. So 5 over 3, now let's come back here. So then we say 5 over 3 equal to 5 over 3. So look, mathematical, say this, mathematical, in mathematics, if somebody give, let's say 1, oh my God, somebody give 1 over, let's say x equal to 3 over 7. Find x. Only if you have a 1 group in here, 1 group, you can flip is acceptable. Say x over 1 equal to 7 over 3. Very acceptable. Very acceptable. And the x over 1 is just x. So it's going to be x equal to 7 over 3. So same thing I'm going to do here. Since I want to get resistor parallel here, what I'm going to do, because I got 1 group and I got 1 group. Do not do that if you have another plus another group. No. So that's why we put all this together to get that. So what we're going to do here, I can flip it. I say R11, R parallel over 1. R parallel, you can use P over 1 equal to 3 over 5. But anything divided by 1 is that's something. X over 1 equal to X. So R parallel over 1 equal to, just say R parallel equal to 3 over 8. Ohm. Ohm is the unit of R. So now let's come back here to our actual question and solve a question, because this was just explanation for you to understand. Another thing which is very crucial here, the last one. Like I said, you won't be able to solve this question if you don't understand the concepts. If you have, look, parallel resistor, because for series, we remember we say each one is going to have different voltage. What about parallel? If the resistor in parallel, they use single voltage. Means this is going to, if let's say this is 3 voltage, the first resistor is going to use 3 also. The second resistor is going to use 3 voltage. Even the last one is going to use 3 voltage. Because they're in parallel, they're going to use single voltage. Now, let's go to the question now, because this was not part of the question, but it was very, very crucial for you to understand or to go through this for you to be able to solve this question, right? Now, how did I say here? They say total external resistance of a circuit. Okay, so external resistance, we got 2 resistors here. We got this, which comes all the way, and then is series to these 2, but these 2 are parallel to each other. Let me find the resistor parallel phase, and then when I get this, I'm going to add to this, because the resistor 1 is series with these 2 which are parallel to each other. So now I'm going to say, let me find resistor parallel phase. So resistor parallel, no, you cannot say that. We say 1 over resistor parallel for parallel. 1 over resistor parallel, or resistor total parallel, equal to 1 over the phase resistor, resistor 2, plus 1 over resistor 3. Oh, which we got 1 over, this is 25, plus 1 over 15. So 1 over resistor total, resistor parallel equal to 1 over 25 plus 1 over 15. 1 over 25, 1 over 15. You can plug in a calculator if you want. If you don't want, you can simplify slowly. Okay, so 1 over resistor parallel equal to, I can cross 15 times 1, or you can put in a calculator. It's going to, okay, 1 over 25, 1 over 15. 1 over 25, 1 over 15 is going to give us 40 over 375. It's going to give us 40 over 375, but I can do slowly. So what we do, I can flip it acceptable, just like I would say. So it's going to be 1 over, so we flip it. So when you flip, it's going to be a resistor parallel, or you can use P if you want, or you can use those sign here, which is parallel. Resistor over 1 equal to 375 over 40. 375 over 40. So resistor parallel equal to, resistor parallel equal to 9.375 ohm. Oh, so this is total resistor parallel, 9.375. Okay. So all this total here of these two here is going to give us what? Resistor parallel equal to 9.375. Now, okay, so if you're in exam, make sure you make all these work out to the part of your solution. That's how you get the marks. Otherwise, you're not going to get marks, okay? If I'm marking you, let's say I'm not going to give you marks if you write me shortcuts. Now, we say, look, so this one, which is 4 ohm, is in series with these two, which we got, which is what is 9 point. Okay, let me say. Okay, let me do this. Excuse me. Resistor 1 is in series with these two resistors, which is resistor 2 and resistor 3. If you have to straighten this diagram, so for that case, this one I have equal to 9.375. I'm gonna have to add with the resistor, which is 4, because this is series with that. Okay, so now I'm gonna say 9.375 plus. So I'll say resistor total, resistor external, that's what they're looking for, equal to 4 ohm plus 9.375 ohm. So the resistor external total 13.375. Okay, cool. Now we got that one. The next thing, the one, the EMF for battery. EMF is easy, man. Use a very simple formula. EMF for battery, you say EMF for battery, EMF equal to current times external resistor plus internal resistor. This formula makes you memorize. Okay? Current times external resistor, that's big R, represent total external resistor. So now we're going to say EMF. Current flow, we know. Current flow, we already had is 3 ampere, which is going to be right here by the ampere. 3 ampere. Okay, external resistance total, we have 13.375. Plus internal resistance, we have 0.5. And then that equal to, if you plug in the calculator, it's going to give us our EMF equal to 41.625 ampere. These are our EMF for battery. Done. You see what I'm saying? Now, we want to go to question number 8.4. So let me explain to you something. 8.4. Okay, so this 3 ampere, right? We know. If this current come here all the way, remember this is supposed to come all the way, but when it comes here, it's going to split. Someone's going to come here, someone's going to come here. But we don't know the amount of current which is going to pass here. If this is resistance 2, this is going to be current 2. If this is resistance 3, means this is going to be current 3. And then it's going to come and join together, which is going to give us again 3 ampere. But remember, these two resistors in parallel means they're both going to use single voltage because they're in parallel. So let me find this voltage. Oh, I'm going very fast. Let me go back and read the question. We'll do the one because I'll be cheating if I do that. They say Elena makes the following statement. Which statement? They say the current through the resistor R3 is larger than the current through the resistor R2. They say the current which is going to pass here is going to be big. Oh, it's going to be this R3 is bigger compared to that R2. That's how the statement say. So is it true or is not true? First, before even I solve, I know for me it's going to be true. You know why? Because look, if this current come here as a 3 ampere, and then it's going to split, but I don't know how much is going to pass at the top and the bottom. But just by looking, here is going to be less current passing because it's going to be more resistance. 25 is bigger than 15. Means it's going to say, you want to come this side? I'm going to stop you. I'm going to resist you. Like, don't come here because I've got bigger resistance. I resist you. Which is what? 25. But here just a 15. So means here, obvious, less current is going to pass compared to there at the bottom. So now let's prove mathematical. Because here they say, is yes or no? Answer, yes or no, and then explain the answer. So to explain the answer, you could say phase in resistor 2 is bigger compared to resistor 3. Oh, resistor 2 means if the resistance of resistor 2 is bigger compared, means less current is going to pass from the Ohm's law. And here, since the resistance is less compared to R3, means more current is going to pass. Now, that's to get 3 marks might be not enough. Let's show mathematical. Me personal, since I know the total current of here, which is 3 ampere, even though it's going to split, but the total of them is 3 ampere. So now let me find the total voltage. I'll say from the Ohm's law, V equal to IR. That's called Ohm's law. So now I want to get the total of this. Look, I know the total resistance here for the 2 means resistance parallel. So okay, so this is only I want to get here. Current passing, I know 3 ampere. Let me get voltage, which I know is going to be common for both. The current is going to be 3 times the resistor parallel total. We had it before, which was 11, which was 9.375. So 9 means if you find the resistor parallel total, you know how to do that. For these 2, which we say 1 over resistor parallel equal to 1 over 25 plus 1 over 15. And then work it out this and then put them together, flip, and then flip also this part is going to give you what? 9 point that. So our voltage equal to 9. Our voltage for this 2 is going to be equal to 28.124. 125, sorry. So this is going to be voltage for each one. So I'm saying, means since these are parallel, means each one is going to use the voltage for 28.125 voltage. Now we want to know, okay, what are the current? Make sure you show all these. These must be part of the solution. All these I'm showing you the part of the solution. Now we're going to say, let me find the current which is going to pass here. So I'm going to say from Ohm's law again, V equal to I by this current 2, let's say, a resistance or resistance 2. I want to get the current, so divided by resistor 2 divided by resistor 2. Or you can simply say, look, do you have a voltage? Oh yes, because the shade is going to share the same common voltage, 28.125 equal current 2 I don't have times resistance 2. Resistance 2 we know equal to 25. So divide by 25, divide by 25. This and this cancel, so current 2 equal to, take a calculator, plug in the calculator, 28.125 divided by 25. And this is going to give us 1.125. 1.125 what? Ampere. Or you can say 1.13 if you want to approximate or write like that is option. Okay, so now we know the current which is going to pass here on top. Here on top, it's going to be what? 1.125 what? Ampere. But look, if all this current is 3 ampere, and then if it's going to split, some up, some down, if the top one is going to be 1.125, what about the bottom one? Look, the total 3 ampere, and then it's split in 2 parts. Some goes up, some go down. But I know the one on top. So how about the down? Also, okay, total current minus means take all minus the one on top, which is what? Current 1, current 2, because past here there is 2, is going to give us the one which is left at the bottom. Current 3. Does that make sense? Means our total current is 3 ampere here. And we know the one which is going to pass on top, which is 1.125. So to get to the bottom, we just take total minus the one which is passed on top. It's a total 3 ampere minus the one passed on top. It's going to give us the one at the bottom. See, easy. So we're going to say current 3 minus this current, which is 1.125 ampere. And this is going to give us 1.875. It's going to be 1.875 ampere is the current which is going to pass at the bottom here. 1.875. We can say 1.88 if you want to approximate. So now if you look, we see it's true, because this current now is bigger compared to that. 1.8, this is 1.1. Like I say, because here the current is going to be bigger because the resistance is smaller compared to this resistance 25. So since it resists less, this means less resistance compared to that, means more current is going to pass. I resist you less means I don't give a problem. Means what happened? It's going to pass. So here is going to be more current compared to the one which is on top. So we're done. So the statement is true, and the mathematical, this is how you show, and this is how you prove, and you should make it part of the solution. We're done with that? Now we go for the last question. Oh, off your face a little bit. Last question. So go to the last question here. Excuse me. So the last question they say, let's do the last question here. Sorry about that, somebody making noise outside. Okay, cool. The last question here they say, man. The last question here they say, the last question, yeah. Now they say the resistor 4 ohm is now removed. Oh, so they remove this stuff here, means it's not there anymore. Okay, now will this affect the EMF of battery? No, it's not going to affect. You know why? Because EMF of battery is always here. EMF is inside the battery. So removing the external resistor is not going to affect this. So meaning they say is the EMF is going to increase, decrease, it's going to remain constant. It's going to remain constant because EMF has to do with the internal of a battery or other battery. So this is an external resistor. It does not have any effect on EMF. So it's going to remain constant. That's the answer. Look, like I say here, man, you know, if you first time here, please come here, subscribe, you know, subscribe here so that every time when I upload a new video and then you're going to get the notification, okay? And then you can get to see what we do for the community, go to the various place, giving back. And on top of that, this is very, very most crucial thing. Please come right here, okay? Just go to my YouTube channel called Untitled Chapter. See, there we have a feeding program, feeding the homeless, vulnerable people, more special. You know, we don't want to have to do something for community, because, you know, if we don't wait for the people doing for us, means we're gonna grow up, you know, our kids, even them, because most of us come from the disadvantaged community. We grew up believing that we don't have a solution. People from outside, of people from the Western world or Eastern world, that want God who have to give a solution. But we could be the one of our own solution. We're the provider. We're the protector. We're the warrior. We're the king and queens. We can provide for our people around us, okay? Meaning, you can do something for your community. Go and do something, okay? This society, these are all projects to inspire and help, especially vulnerable people, people with mental disability. But this is in my own independent projects that I do. So, you know, we appreciate any type of donation whenever it's convenient for you, so we can keep these projects going, but no harm, no falsehood. Only if it's convenient for you, and if you're comfortable, you're more than welcome to give donation under the link below. And a platform that you can follow me in all the social media means go to Untitled Chapter. See, this is not a YouTube. This is not a platform where you can go and do, you can find my merchandise too. You know, link below. I sell also merchandise and different products in my online store, in my digital platform, okay? So, man, that's me right here. When I was 4th grade with my friends called Amar, and this is a Rasta guy. His name is Kisei, okay? Kisei, that's my Kisei, Kisei. See, that's our big brother. He used to be a big brother, man. He was very, very conscious That's me and my mom right here, okay? So please, man, have friends with a nature afro. So come subscribe here, okay? Subscribe to platform. You can see Tumtwana Nkosi, and you can see what we do to the community. Feeding program, helping community, giving back, you know what I'm saying? Do not try to give back. Giving back is a blessing, because the more you help somebody, means it's open more door for you, okay? Thanks so much for your support. Visit my lounge store, give donation, donate to our page so we can keep these projects going, okay? Thanks a lot for your time, man. And subscribe, like I say here, come subscribe to this present current YouTube channel, Trying Our Bantu Academy, and Trying to course, man. I love my brother and sister from the continent. See, I love helping people in the community, because, like I said, everything's mindset. So if your mindset is tucked up, like, I cannot make it before people helping me. You know, I was in the same position yesterday, but because of the inspiration of praising Magufuli. That's what I say. I'm Magufuli, because he inspired me, because he was giving back to the people in need. At the same time, also, you know, I got a lot of inspiration from the Master P, from the Kalia projects, because this man here, he do a lot of things for the projects, inspire people, go back and give back to the community, and have entrepreneurship mentality. But whatever you do with your own hustle, entrepreneurship, don't forget where you come from. Don't leave your people behind, because for you to get success, you need a team. And pick a team for where you come from. Go and get your people come from. Sometimes people need training, because they might not think the same way. They may not take serious. So you need to provide training to your people, inspire them so they can stand on their own 2 feet, so then we can make this world a better place, man. Thanks a lot for your time, and I'll see you very soon, okay? And I'll be back soon. I hope you learn from how I do things, man. Thanks a lot, and thanks for your support. That's what's out of all these online platforms, so where people can benefit this program almost for free. I'll say almost for free. You see what I'm saying? Thanks a lot. Peace and amount. We'll be back soon. We're trying to course.